Hello everybody and welcome to Robotech's webcast on how Autodesk MEP Fabrication solutions work. My name is Mark Henze and with me is Jeff Krentar, Robotech's Senior Technical Representative. Autodesk produces a variety of products that assist in the MEP design to fabrication process. This process can often be difficult and utilize disparate kinds of software. Robotech CAD Solutions has been in business since 1983 and a provider of CAD and BIM software and implementation solutions. There's a lot of challenges in the MEP design to fabrication industry. If you're a contractor, you may be managing multiple databases. You may be experiencing design or design intent models that don't look like they're constructible. There's additional problems with material management or material handling. Sometimes contractors struggle to engage early in the project cycle. You also need good access to good quality content and the ability to collaborate with other trades. Part of the problem is the silo approach to data handling. An engineer amasses his information and dumps it into a silo, which then goes over to the detailer. The detailers do their job and then hand off everything to estimators, who in turn hand off everything to fabricators. This silo approach is often fraught with inconsistencies and inability to manage data in an efficient manner. Here's a typical MEP contractor workflow. At the center of this workflow is rework and checking, and a cyclical nature of going out to the field, resolving problems with, again, attendant rework and double checking of the results. So to summarize, our concerns are detailing and redrawing time, revising our drawings per estimation that is, time to manually enter data for fabrication, errors and inconsistencies in the field, and associated rework. So here we're asking you to imagine that you're going to be on one authoring platform that has a single spec-driven database. These solutions from Autodesk don't require that you invest any time for remodeling. You're going to be using the same model in the field as you are in the shop. A single database for job costing, labor, and procurement. Here's a simplified workflow showing what happens when we use the MEP fabrication solution. As you can see, everything works off a common database, allowing exchange of information easily between the detailers, the estimators, and the fabricators. Also, you'll be able to generate barcode information and information that assist in field assembly. And now, without further ado, Jeff is going to show us how all this stuff works.
Okay, so here we are in Revit, and for the first part of our presentation, we're going to take this Revit design intent system and convert it into an SMEP fabrication intent system. So in this scenario, we were provided with a Revit model, and by using the design information already created in the Revit model, we can greatly reduce the time and effort needed to create detailed cost estimates. So the first thing we need to do is we're going to take the design intent model and convert it into the fabrication intent model. So you may be asking, what's the difference between the design intent model and the fabrication intent model? Well, the design intent model in Revit was used to perform calculations to make sure it meets all the requirements of the building and its occupants. So it takes things into account like the spaces, the zones, the occupants, and how those spaces are going to be used. And then the fabrication intent model really shows in great detail how the HVAC system is going to be constructed. It shows things like the seams on the ductwork and the hangers and how things are supposed to be put together. So first we're going to take this and we'll convert the fabrication model. To do that, we'll use 3 different commands. On this add-ins tab, we'll use the store design line elements, store graphic elements, and we'll push things out. So in Revit we have system families and we have loadable families. So things that are system families like ducts, pipes, cable trays, straights, and fittings, we will use the store design line elements tool for that. And then things that are loadable families like Revit, the air handlers, the pumps, lavatories, those things will use the store graphic elements. So here we go. We're going to just select everything here. I'll go to the filter and only select things that I want to store as design line elements. We'll go to our add-ins tab and push them out, use the store design line elements. Now I'll do another selection again. I'll do another big selection. Go to the filter and only select the objects that we want to store as graphic elements, like the air terminals. So if I go to this add-ins tab here, we could say store graphic elements. Good, so we use both of these. Now we're going to push it out and it's going to store it as an RIF file, a Revit export file. I'll name it export from Revit. Excellent. So that's the first part. Now we're going to go to SMEP. So here we are in SMEP, and we'll create a new job. We'll create this blank job. Little glitch there. Okay, so we're in SMEP now, and we're in a new job, and we're going to import that run of items that we took from Revit. So import run of items. We'll find that file that we just created, export from Revit. And in Revit, everything is a system, but in SMEP, it's a service. So we have to tell it what system it was in Revit and map it to the correct service in SMEP. So here it was a supply air system, and now it's going to be a service. The service is supply air. You can give it different specifications like ductwork. We'll go to the fitting ignores tab here, and some of the things that we're going to bring in, like our end-of-line items and our inline items. End-of-line items are diffusers and plenum boxes, while inline items are fire dampers and access panels. So we'll bring in those types of objects, but other things like here it says rectangular duct and the different types of ducts and things that these SMEP already knows that if it was this type of system in Revit, that it's going to be this type of service in SMEP. and that service knows what type of ducts to use and those types of things. But things that you do have to map out and you have to tell it, the end of line items and the inline items. So you'll notice here, those are the things that say no. We're not going to ignore those items because we want to map them and tell them what type of items that they will be in STMEP, while the ones that say yes already know how they're supposed to be imported. So if I go back to the Services tab up here and I right click on our service that we're bringing in, and I'll say Map Items. So the things that we just said no, don't ignore, those are these here that we have. The fire damper. Well, if it was a fire damper, we're going to map it to this type of item or in this type of item. All right, so we can hit OK and hit OK. And now it brought these items in. I'm going to do a zoom extent and see everything here. We could go to our 3D view. So you can see it's much greater detail than the model in Revit. It shows the different seams and it shows the hangers, and we could get real good information that's needed to fabricate the system. So I'll go back to the top view here. Could double click on one of these objects like this ductwork, and you'll see that it has a lot of information. Things like what seams there is, what types of, you can see here the different connectors and all this information. This came in from the design line, the store design line element, while this came in as the graphic element. So these are all individual items now, and having all of these individual items, we could get a list of the different items that are needed to fabricate the system. So there's an items tab here that we can click on. And we get a long list of all the different items in this system. Having this list of items, we could then go to the estimating summary. And we can create cost estimates. So we'll talk more about how it gets all of this information later. You know, it knows the different items and the cost of those items, and it also has labor costs in there, and we'll see that a little bit later in the presentation. So for now, we took our Revit model and we converted it into a fabrication model that we later brought into STMEP, and saw the different items and the different ways we can estimate the cost here. Okay. Okay, so a minute ago we had a Revit file. We were provided with a Revit file, and we used the store design line element and store graphic element tools, and then we pushed it out to an RIF file. We then went to STMEP. We created a blank job, we imported that RIF file, and then we were able to get information from that new fabrication model. We saw the different items. You get information from each item. We saw a detailed list of all of the items. And then we even had a quick look at the cost estimate. Well, this time, we're in a different scenario. We were provided with a 2D drawing. It could have been an AutoCAD file, could have been a PDF, but now we need to take it and convert it into a fabrication model. So we're going to create a blank job again. And we can turn on O-snaps. So just like in AutoCAD, you have O-snaps and you can choose which ones you want to turn on. You can hover over them and it'll tell you what each of these O-snaps is for, and you can choose which ones you like. But then I'll right click anywhere on the screen, I'll do import underlay, and I'll bring in the AutoCAD file. Now there are a lot of different file types that you can bring in here, but we're doing AutoCAD, and we'll bring this guy in. It's asking us which layers we want to see. We want to show all of the layers, so we're just going to hit OK. And then we'll click somewhere to place it. So this AutoCAD file, This AutoCAD file came from model space in AutoCAD, so it was full scale. But if we had a PDF or something that was on a sheet and we had to scale it back up to full scale, we would be able to do that too. But in this case, we don't need to. It was already full scale in AutoCAD. So now we're going to start tracing over it with this design line tool. Now, here it says new design line, and we can use this tool to draw our ducts. Now, if we go back in time for a minute, you may remember when we were in Revit, we used the store design line elements command. So going back to Revit, you'll see here store design line elements. Remember, we used that when we were taking the ducts and converting them into our fabrication model, and it stored them as design lines. Well, now in SMEP, we're going to manually use the design line tool to draw our ducts in ourselves. So we'll click on this design line, tell it what type of service we want, the supplier, and we could give it different criteria like the types of ducts that we want to use. You could enter information like the size of the duct, and we'll be getting that information from our AutoCAD file. So each of these ducts has a tag on it letting us know what size we want to use. So I'll just go ahead and type that in. And give it an elevation, a height. Good, and just like in AutoCAD, you're snapping to these points. So I'll type in the next one here is 32 by 22. And I'll click on the end of this one. And then we have 30 by 18. And then 24. Okay, good. So I'm just going to right click to let it know that I'm done drawing ducts, and we're still in the command so we can draw more. And I'll change the size. It knows it's a round duct because I'm only putting in one dimension, and we could even give it a termination height so it knows to turn down towards the air terminals. Good, so just snapping. Look how we're going to draw right through that other duct. I'll right click, draw the next one. So we could continue doing all of these, but we're not going to do all of them. But we can look over here where we have a more difficult one. It makes a couple of turns. So just like in AutoCAD, you can track off of objects. You could do the same thing here. You can track off of that midpoint there. Excellent. So now we can start putting in our air terminals. And we're not going to do all of these. It's just repetitive, but you can see what we're doing. We're just going to kind of put these round diffusers in here. And if it doesn't look 3D right away, don't be too concerned about that. You'll see in a minute it will be. Okay, so going to our 3D view here, I'm just going to switch up to a 3D view. You'll see that they don't look three-dimensional yet, but there is a really great fill-in 3D tool here where you could click on it and then it'll update it with the new 3D diffusers. So in this scenario here, we manually drew it ourselves because we didn't have a Revit model, a nice smart Revit model to steal information from. So we saw that you're also able to do that right in AskMEP, where you can create your own fabrication model. Now, one of the really great things about when we did it in Revit, you didn't have to be a Revit master to do that. So you only had to open up Revit, select a couple of things, and do store design line elements, but you don't need to learn, you don't need to completely learn Revit front to back and be a master of Revit to be able to do something like that. So it's some pretty great tools there. Okay, so I'm going to save this. Okay, I'm saving it as another MAJ, just like the other one. And I'll just type draw. This one we manually drew it ourselves. Okay. Okay, so we're done making our fabrication models. We made one fabrication model from Revit elements, and we made another one from our 2D AutoCAD drawing. And now we're going to start creating details. And we'll do that in CAD MEP. So let me switch to CAD MEP. Okay, so here we are in CAD MEP, and it should look pretty familiar. If you look at it, look, it's AutoCAD. So it's AutoCAD with a bunch of extra tools inside of it. So the interface should look pretty familiar. And we want to bring in one of the jobs that we were working on earlier. So I'm going to type open job. And I'll find that draw one that we made. Okay, so yep, and we'll bring everything in. And this is what we have so far. So I could flip up to 3D and you can see what we have so far. Just like in AutoCAD, you could turn your grid off. We can change to different visual styles if we want to see it in conceptual. But we're going to switch it back to 2D wireframe just to make it easier to work and look at it from the top. Okay, so now we're going to start creating spool drawings, and when we create the spool drawing, we'll use this great tool over here. And what it's going to do, it's going to create a separate drawing with just the elements that we select, and it'll put them in a layout for us. So you can tell it where you want it to store the drawings. So I'm going to change the path here to store it into our presentation folder. But you could also define a template. So if you have an AutoCAD template that already has all of your layer standards built into it, and your CAD and your textiles, dimension styles, could have your layouts with your title blocks. If you have all that stuff already built into a template, you can set it to go in here. But we're going to just use the one that comes with the software. I'll hit OK. Now I'll select everything that I want to create the layout from. And here we are. So it's AutoCAD. We're in a layout. It's has a title block. It's not the prettiest title block, but like we said, you can put yours, your template in there, so it would have how you like your layout set up. And just like in AutoCAD, you have your viewport scale, so we can make some changes in here, and we can set a scale to it. Zoom in and out and pan. When you're finally done changing the scale and setting up that viewport, you can lock it so you don't change it by accident. And then look over here, it even comes in with a table with all of the different parts that you have in that drawing. So it's very smart. If you zoom in very close, you'll see each one of these pieces of duct. They all have a tag on it. They're very small, but we can change the text size. So let me just go ahead and type in text size. And I'll scale it up a bit. And then we'll do a regen. There we go. So we have all these tags in here. And the tags are pretty cluttered right now, but we can move them around. So if you select them, every one of the tags has a little grip on it that you can drag it around. And it even has this cool little triangle. If you click on this triangle, it'll add a leader to it. So you can move these tags around and you can make it easier to read. And we're not going to do all these, we'll just do a couple of them here. There we go. Good. And now we can start putting some dimensions in. So there's a really great spool dimension command. And we can start adding dimensions. There we go. Good. So we just have put our dimension in here, and we can change different dimension styles. So if I go to my annotate tab, we could click on it, and you can see the different dimension styles that you have in your template. If you brought your own company template in, you would be able to choose what dimension style you like to use. Good. So we can continue, adding more tags and text and dimensions and creating our details, and you could control the visual style. If you want it to be in conceptual or realistic or something, you can change it here. And it's very similar, it's just like AutoCAD, a lot of the same tools that we're doing by editing the viewport scale and adding text. If you want to add text, or the spool dimension command is really great. You could use the regular AutoCAD dimensions tools as well. They'll work as well, but the spool dimensions are a little bit easier to snap to and align to the specific duct. So those are really great tools. Okay, I'm just going to save this. It's just an AutoCAD file, nothing crazy. It's just a regular AutoCAD file. Good, and I'll close it out. Good, and there's our original AutoCAD file that we first started with. Excellent. Okay, so we saw how to convert the Revit model into a fabrication model. Then we converted a 2D AutoCAD file into a fabrication model. We did a detail, and now we're going to see how we got that cost estimate before when we were in SMEP. So let's go back to SMEP. Okay, and we're going to open up the job that we were working in. So I'm going to go to Open Job, and we'll find the file. This is the one that we exported from Revit. Okay, good. So, we saw earlier that it has this estimating summary, and, it calculates the cost of the job for us. But how does it get all that information? How does it get the cost of the materials and the cost of the labor? Well, that's all built into this database. So if we click on this database, there's just tons of information in here that you can enter, and it'll help create the cost analysis. So if I click on costing, there's price lists in here, and this is how it gets the information for how much the materials will cost. So it's based off of this Harrison pricing data, but there are a lot that we can choose from. Or if you're calculating labor, we could click on this guy, labor rates, and you can choose different levels of labor, skilled labor and low skilled, and give them different prices, high skilled. So this is how it calculates the cost for the job. So it's all very smart, and you can edit all of this information to meet the needs of your project. Okay, so now that we've created the fabrication model, and we've done the details, and we also saw a little bit about how the cost calculation works. Now we're going to go into CamDuct. So I just opened up this guy, CamDuct, and if we go to Open Job, we'll open up that same job that we were just working in. Oh, it's still open from my SMEP, so let me close that out. So here is CamDuct. Let's see. Okay, so here we are in CamDuct, and if I go here to nests, it shows us these three images here, and these three images represent different pieces of sheet metal. So we have three pieces of sheet metal making all of the cuts to create all of those items. And if I click on these three, I can right click and say write NC. Good. And then when I click on one, I could say view NC default, and then this here is one of those pieces of sheet metal. And if each one of these lines represents a movement made by the machine that's doing the cutting. So if I kind of just start going over these, I'm just holding my down arrow on my keyboard and I'm going through all of these different lines, and it simulates the movement that the cutter is doing when making all these cuts out of the sheet metal. We can see different reports and different labels if we go up to this file, print preview. And there's different types of labels and different types of reports that we can take a look at. So I'm going to check some of these. Okay. And here we have this little print preview, and there's this other little dialog box here that lets you switch between the different reports and different pages. So here is nest labels. Here we have nest labels, and you can click on this arrow here and it'll switch between the different pages. So this one's only one page, so there's nothing to switch between here, but if you click on the plus sign here, let's see, what do we have now? Okay, so these are part labels, and there will be a lot of different sheets that we can choose from here. So see, we're switching between different labels for these parts. So you can put the labels on the parts, and then when they get to the job site, they'll know what part goes where. We also have item labels. Material usage. And nest reports. And then back to nest labels where we originally started. So these are all things that we can print out, and we can put labels on the objects, on the items and the parts. And it's a very smart tool, and this is CamDuct. So we've taken a look at SMEP, CAD-MEP, and CamDuct, and they were all sharing the same file type, an MAJ file. An MAJ file is really great because you create it. We created it in SMEP, but you can really create it in any of the three, and it's used by all three pieces of software. So it's a great seamless workflow. Okay, back to you, Mark.
Thank you, Jeff, for that wonderful presentation, and thank you everybody for joining our webcast today and taking the time out of your busy schedule. I hope you've got enough information now so that you can see exactly how Autodesk solutions drive design to fabrication using design line technology. There's a variety of ways to get these products, each dependent upon individual situations. So we'd like to discuss what the best possible way to get these products are and implement them, and do a needs analysis for you. So feel free to give us a call at area code 201-792-6300, and myself or another company representative will be very happy to assist you in determining the best possible way to streamline your design to fabrication process. Thank you again, and have a great day.